go through what we did in the last class. Okay, so for today's session in software engineering, we'll be looking at planning, estimation, and processing. Now, software engineering basically has a life cycle where other specialization are focused on or revolves around. That life cycle is very, very important in any specialization in software engineering, be it web development, be it mobile development, be it app development, or cybersecurity or networking, as the case may be. This life cycle is very, very essential. We also learned about the SDLC, which stands for Software Development Lifecycle. And in there, I think I listed out those software development life cycles we have and their essence. So please, if my screen is up from your end, I would like a thumbs up so that I will know my screen is active on your end. Please, even though it's a mirror screen, just ignore that. Normally, I'm sharing the entire screen. All right. Okay. Okay, let's proceed, please. Back to the stage. Okay. So software engineering. Okay. Okay, so we're looking at the table of contents, which is software requirements, planning, design, and architecture. And here we have some few things we'll be looking at: requirement gathering techniques, use cases and user stories, which are very, very important for your design or your UI, project planning, estimation, and principles of software design. These are all with two topics. And also design pattern, system architecture, and modeling, UML. I think in the last class I threw the question on the meaning or you guys should do a research on the meaning of UML. Though we'll still be looking at that properly in the next class. So for today's class, we'll be looking at project planning, estimation, and principle of software engineering. But before we look at what we're going to be doing today, we have to go back and start with, or we have to look at the previous classes. So before we do that, we start with software requirements. Now, these are description of features and functionality of the target system. They serve as a foundation for the entire development process. This requirement, it serves as a description of the features and functionality of the targeted software you're trying to design or trying to build. The software might be a web application, it might be a mobile application, it might be a machine learning or AI application. So it all depends. Now, the requirement gathering simply means what and what tool would I use to build this application? Why am I using this tool? For instance, the tool can be a programming language based like Python or C++ or any other related programming language. Now, you need to ask yourself, in terms of using this programming language, what is the flexibility or what are the flexibility this programming language offers? Why does this programming language offer this flexibility? And how can this programming language be scalable across all platforms? So those parts are considered under the software requirements. The next you need to ask yourself is the end goal. Which users are going to be using or consuming this platform or using this platform on a website or a mobile app? What and what should they see, and so on and so forth. All those parts are considered under the software requirements. Now look at types of requirements. There are two types majorly. We have one, functional requirements. This one describe what the system should do, which I just explained now. What and what my system should do. Like if I'm designing a mobile app, for instance, and I want this mobile app to be like a booking system. So I want the user to come into this mobile app, place booking, for any kind of let's say hotel or maybe a place they want to visit or any kind of thing, and so on. And how the interface will be friendly to the user is very, very key. All those things are termed the functional requirements. The next one is called the non-functional requirements. This one specify how the system should perform. Now, once they book that system, where should they be redirected to? Why should they be redirected to that page? What and what is needed for them to do next afterwards, visiting or inserting their details, their booking details in the booking site, for instance. So the non-functional requirement has to do with performance, security, and usability. These two functionalities or these two requirements in softwares are very, very essential for any kind of software you want to design, be it a website, be it a mobile app, be it a cybersecurity kind of site, or a cybersecurity kind of infrastructure, or a networking kind of infrastructure. These requirements are very, very key to consider. Now, we looked at the next one, which is planning. Now, planning, this involves outlining the project scope, objectives, timeline, and resources needed. So I don't think I have to break this one further because the definition itself in there has brought out what we need to know about planning, the project scope, what are the objectives, what are the timeline, how long would it take me to finish this project, and the resources needed. What are those resources that have to be in place? I know that while building a project like this, I might need constant internet, I might need data, I might need other research sources or academic sites where I can get information concerning what I'm trying to design to see if relevant design has been done. So planning is one of the stage there. The next stage is design. Now, all this thing I'm listing out here have been listed out before, though, for those who attended the class last week, where we discussed about SDLC, Software Development Lifecycle. So in there, you'll be looking at most of these steps I'm looking at now. Now, the design, the process of defining software solution to one or more set of problem. Now, what is your software trying to solve? Are you trying to build a software that would eradicate the aspect of here in Nigeria, basically, we need softwares that can help us eradicate the aspect of we going to vote manually. Let's say for voting, voting manually is not ideal in most cases or in most systems. So understanding how this thing works will depend on your design. Okay, the next one is the architecture. The architecture, sorry, is the high-level structure of the software system, including its components and their relationship. What will be involved? Now, what is the what are the steps taken? Why are the steps taken? All those guys are classified under the architecture and also the design aspect of it. Now, the next one we'll look at is system requirements. Now, these are various requirement gathering techniques using software development and engineering. Common techniques include, the first one is interview, a one-on-one or group discussion with stakeholders. Stakeholders are like people of hierarchy. Like in a company now, maybe you want to design a kind of a flow in that site. Just let me give an instance of the kind of company I worked with back then, a real estate company. And in that real estate company, they have different hierarchy. And I mean hierarchy, they have different stages of different departments in that company. The company was divided into, I think, 5 different sections, 5 different departments. Since it's a real estate company, and they're also into facility management, so they have a part of the company that has to do with what control and planning, control and operations, which is one of the departments. They have another department that has to do with what operations and planning. They have another department that has to do with what bank, anything finance, all them finance, and they have another part of the department that deals with anything real estate. So you're divided into stages like that. Now, those departments needed different softwares to carry out different functionality in that estates, in that real estate firm. So the softwares they were using was were specific for different purposes. They were specific for different purposes. The reason why that was the case was because the software used by the control, as the central operations and planning departments, was different from the software used by the finance department. The reason is because the finance department has to do with money, and the control, central operation and planning department has to do with the facility of those estate itself. So there was a need to demarcate the kind of softwares those guys used and so on. So an interview, a one-on-one interview or group discussion with stakeholders will give you an idea of what kind of software a company might like to design. The next one is a survey slash questionnaire. For those of you who I'm pretty sure that we have some graduates in the house, or most of you we are who are still undergraduates in school. Questionnaires are actually like templates you can fill based on your need or niche on some specific questions. It is graded based on numbers or reward, something like that, to outline what and what you feel or is best need to be put in place to achieve what and what you need at the end of the day. So those are surveys slash questionnaires. The next one is observation. Observation simply means watching user perform their tasks. Okay. For instance, if you're designing a site where you want to allocate different kind of permissions or roles to a user, the observation aspect has to come into play. So you know that a user who is logging in as an admin should have a different privilege from a user who is logging in as a normal staff. So the observation aspect has to we handle that aspect of the requirement gathering techniques. The next one is the document analysis. Document analysis. I think this word is kind of I think it's a wrong analysis. Sorry, it skipped my mind. Thank you for that. Document analysis, reviewing existing documents, checking few other concepts and so on. That's the document analysis. So sorry, it skipped my mind that I was pronouncing the wrong word in using the wrong statement. The next one is prototyping. Prototyping is just like creating a kind of it's just like creating, if you want to build a software, there's a way you have to prototype the software in such a way that the prototype might carry out the same functionality as the main software, but just that it's going to be different. The prototype might not be used at the end of the day by the end user, while the main software will be the one to be utilized at the end of the day by the users. So it's creating a basic version of the system for feedback. That is the essence of prototyping. The next one is joint application development, JAD session. These are workshops with stakeholders. So you keep carrying out different calls or different sessions with stakeholders to see what they need and see what needs to be put in place. It's just like instance, a friend of mine is trying to design an LMS platform, that's a learning management system platform, and after testing the platform, he needed other people to test this platform. So he has to start marketing his business by going around to schools and selling what he has. So there was a particular school he was able to onboard to that system. And after onboarding that school to that system, the school discovered some errors which were like minor to the developer himself who was marketing this project. So at the end of the day, they had to tell him the error they discover and how to go about those errors. So him as a developer, he was able to see that those errors, which he was taken as a minor error, were actually a serious kind of errors and needed to be worked upon. So this aspect of the joint application development helps a lot. Session by session with stakeholders helps a lot to give reviews based on your software. The next one is brainstorming, the group ideation session. So the brainstorming and yeah, the interview is almost the same, because in the interview though you are having a group discussion with the stakeholders, why the brainstorming can be with a fellow developer on how they implemented such platform when designing theirs. Okay. Now look at user cases and user stories. Now, user cases and user stories, we start with user cases. They are detailed description of how a user interacts with the system to achieve a specific goal. For instance, this user cases is, for instance, let's say a user is about to log into a platform. Now, after logging into the platform, he's meant to see it's meant to see different details, moreover, not some different details. It's meant to see different details on his dashboard based on the kind of permission he has to see. So these use cases will just give a detailed description of how that user interacts with the system, what he has to see in his dashboard, how he can navigate from his profile view down to the dashboard, and the dashboard back to maybe, let's say it's a mining site, from the profile, maybe from the dashboard down to the packaging section to buy a package, then from there to the mining page where he has to start mining for the package he has bought. And from there you can, maybe look at some other things like his profile, updating his profile, and also looking at some other things like sending messages to fellow users and so on. Now let's look at the components of use cases. One is the actor, which is the user, the person using the site. The next thing is the system, the site itself, which might be the software. It might not necessarily be a site, as the case may be. It might be a mobile application. It might be an ML or AI kind of based application. The goals, what he is looking out for. So all those things are important. The main success scenario. So these use cases are what the developer we have to consider before designing the software. So they're very, very essential. We have the alternative flow. The alternative flow, what it feels the user we have towards, the route the user we have to take in accessing a website. For instance, when designing a website, like I said, in the course of the software development program or software engineering program, we'll be looking at the web development aspects of software engineering. So in this case, what this use case is talking about is talking about the alternative flow, which is one of the components of the use cases. It's talking about the way the user will tend to interact with the platform. If, for instance, your site is not properly secured, which without proper tests or testing implementation on the site, you'll discover that the user might find in one or two other bugs and can use those bugs to log into your platform, which might hinder you from from achieving the end goal. Because once they have used another route to be able to log into your platform, it simply means they can have access to your database. And anytime they can have access to your database, there's something we call SQL injection. They can inject your database and reformat. And I mean reformat, they can take in, if it's a finance kind of application, they can use that against the users who are banking in that kind of application or banking with that application. So it is very, very essential you understand the routes the user used to access your platform. If there's any other bug or any other way the user might use to access your platform, you have to ensure that you block those ways, or you ensure that you carry out maintenance to as you are maybe coding in the long run, to tell the users that this particular side of this program or this software has an issue. We are currently working on it. So those kind of things will give them information that work is currently going on it, and at the end of the day, a result which is positive will be reflected. Okay, so these are use cases. Okay. Up next is the main aspect of what we'll be looking at today in software engineering. It's called project planning, estimation, and principles of software design. So we'll start with the first one, project planning. Now, project planning, it is a very important phase in software engineering because it provides, that's the grammatical error there, it provides proper project, because it's, sorry, this is a grammatical, a very, very big grammatical error here. Proper project planning enables the user, because, sorry, the it isn't one of the sentences I was supposed to use there. So, because proper project planning enables the user to understand the structure of the application of software before building. So it is essential you understand or you plan your project well before carrying out or before implementing the program itself or the software. Now, project planning involves defining project objective, scope, deliverables, timelines, and resources. It includes creating a project plan that outlines the tasks, the milestone, and schedules. It includes the following processes. The steps involved in project planning include: 1, defining project scope and objective, which we have seen from that definition we had there. 2, creating work breakdown structure. Next one is scheduling taxes and milestone. Next one is resources allocation. Next one is risk management. Ensure that the project or the software is risk-free and users can utilize the software. Estimation, which is the next one. It is the duration the period, the time taken, or the timeline to complete the project. Estimation is a process of predicting the time, effort, and cost required to complete the project. Now, after planning that project, after you know what you're about to design, the next thing you have to consider is the estimation. How long will it take me to complete this project? So estimation, which is the process of predicting the time, the effort, and the cost, and what are needed to be put in place for me to achieve the project. That will come in as the cost requirements. The next one is the techniques. The techniques include in estimation. The first one is expert judgments. Relies on the experience of experts. So once you are done building your software, or before building your software, you can ask questions. Maybe those in the field, those senior developers in the field, you can, screenshot some of your work and send down to them to get reviews on what they think about how far your project will last, or the duration, how they feel about your project or the software you're trying to design. The next one is the analog estimation, using data from similar projects. This one is mostly common to those doing those who are into the data analytic or data scientific field, because in there, since most of the resources are out there, it is easy for them to utilize those kind of use cases and use them. I'm not saying it's limited to web development or app development. No, for those doing web development or app development, there are cases where your application might already be done by another person, but you just have to modify his own source code to meet your own niche or your own need. So this aspect has to do with what these aspects can also help you gather information from extra sources before you start designing your software. Now, parametric estimation, using statistical model based on historical data. This aspect also is mostly used by data analytics or data scientists to gather data, and also ML and AI developers to gather data, though it's not limited to the web developers or the app developers. The app developers can also get data, statistical data based on historical data, and see how those data itself perform over time, depending on the use cases or what they're about to design. The next one is the bottom-up estimation, estimating each order or each component, individually and summing them up. So in the course of this boot camp, apart from me planning a project scope for you, for the assignments which you'll be doing, which you'll be submitting at the end of the bootcamp, I would like a proper project overview, project planning scope, estimation, and so on. I'll give you the other details maybe in the long run of the bootcamp. Okay, principles of software design. The first one we have is modularity. This principle advocates breaking down a system into smaller, manageable parts, modules. For the aspects we'll be looking at in the software engineering session, which is the software development aspects, that's the specialization of software engineering we'll be looking at. We'll be seeing how to follow these principles of software engineering, like this modularity, for instance. We'll be seeing how to break our codes, our programs into different stages, into different modules, so that we can reuse them over time in any course of any other project we are designing. Now let's look at the benefit of modularity. One of the benefits of modularity is that each module should have a specific, well-defined purpose. The module should have a specific, well-designed purpose. The next one is the modules should be relatively independent of each other. So the second module should not be dependent on the first module. The second module should be independent of the first one. It can stand alone, and the first module can stand on its own. Maybe the first module can be user authentication. The second module can be user authorization. So you have to ensure that when you're authorizing a user, you're not authenticating that user. So authorization should stand on its own, authentication should stand on its own. But if you check in the long run, a user who don't have access, who is not authenticated, cannot be authorized. So it simply means that the second one is dependent on the first one. But I'm just trying to give a use cases here, an example that you can actually split different things apart from that user authentication and user authorization aspect of it. Now, the next one is improve functionality or maintainability, by the way, and reusability. It helps to improve maintainability and reusability of the code or the program. Now, it allows for easier testing and debugging. It allows you to test and debug each and every modules you have written. So this module, which is an aspect of what the principles of software design, is very, very essential to consider when designing your software. Now, an example, in a web application, you might have separate modules for user authentication, data processing, and UI rendering. So this is an instance. This example just showed us now that I can have a table for user authentication somewhere. I can have a table for data processing somewhere, and I can have a table for UI rendering somewhere. So it is very, very essential and it's key. Okay, now the next one is abstraction. This involves hiding implementation details and exposing only the necessary parts of an application. Now, I want to believe that every one of us here already have a basic idea or basic introduction to Python itself. I believe that, and if you have idea or introduction to Python itself, please, I'll need a thumbs up from you, by the way. Anyone here with basic Python introductory idea and so on? Okay, yeah, Mr. Ibrahim. Okay, thank you. Please, is there anyone here with any other? Okay, Mr. Ibrahim, go ahead. You have a question to
Yeah,
say, or you're just raising your hand? I will need a thumbs up.
a, 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 a question. Sorry, me. I can't. I don't know if it is my own end. I can't see the screen again. It's okay. Now it's showing. Thank you.
All right. Okay, please. I was asking a question. I hope that everyone here already have a basic idea or basic knowledge of Python itself, because that's the programming language you'll be utilizing in the course of this program. Anyone? Okay. So I don't think I'm supposed to be doing anything complex in this software engineering class. Okay, Emmanuel, thank you. Any other person? If you know you have a basic introductory class or idea of Python, please, I would like to see a thumbs up so that I'll know that I'm not speaking to a total newbie in the Python space. Okay, if you know you don't have any basic idea of maybe programming itself as a whole, can I get a thumbs up? You are new to this space. You don't have any idea about programming, anything related to that. Oh man. Okay. My advice would be that you have to take the data science class so that you can be exposed to some basic of Python, because um, if I try doing that, I'll be dragging myself back. So I'll advise that you attend that session also, the data science session, so that you can have idea of what programming is all about. Because to me, I will believe that you already have this idea, and I will jump straight to coding itself. And if I'm doing this without you having an idea about it, it will be as if um, in the long run you might not learn anything at all in the course of this bootcamp, and that is not nice after attending the bootcamp without achieving one single thing. So please, I would suggest that you take.
Sorry, sir.
Yeah, please go
Okay.
ahead.
Sorry. Why I did not raise my hand off is I started it one time, but my laptop was stolen, so I didn't go far. So I think it was just the introductory part of it. Then those hello pythons and to be honest, I have forgotten what we started because it's been long. I access it since I lost my laptop. But I believe if we start, I think maybe after the first week or 2 weeks, I should be able to remember and then forge ahead. That's why I did not want to raise my hand up in the first place. So I'm not really like a newbie. I have had few things about Python before, but it's been long. Thank you.
Okay, thank you, Mr. Ibrahim, for that. Though what I'm simply trying to say is that in the course of taking the software development or software engineering session, or yeah, I won't be doing anything basic. That's what I'm trying to say. So what I would suggest or what I would advise is that you also apply or take the data science classes also. That I think data analysis classes, by the way, not data science, data analysis classes also, so that it can help you boost your, your thinking mentality to what we'll be doing down here. Because if I'm going back to the basic of Python, we are not simply doing software engineering. We are not doing introduction to Python. Software engineering, just in the aspect of software engineering, what we feel is that, or what we know is that you're already grounded with one or two programming language already, and we are here to utilize those programming language you are grounded with, yeah, and use them to build one or two things. So please, for those of you that has no idea of any introductory programming language at all, please, I would like you to take the data science class so that you can have an idea of what software engineering is. I mean, what programming is all about, or what coding is all about. So that will give you a better edge to understand what software engineering is all about. Please, if you understand me, I'll need a thumbs up there. Okay. Okay. All right. Thank you. Okay, so let's jump back okay, but in the course of this software engineering program, I will try to expose you to most of these programming terms so that you don't get lost along the way. So let's jump back to this. So abstraction, it might be difficult for you to understand this though, but um, and like I suggest, if you also take the data science class, you'll be introduced to classes, and in classes, you'll be introduced to concepts of object-oriented programming, which is something we call OOP. So Python is an high-level language that makes use of an interpreter, or it is an interpreted language. It is an interpreted high-level language. It simply means that when I mean interpreted, it simply means that each block of code in each line we have to be run before the next block of code. If, for instance, you have to program, just like what I have here, I have implementation in the second line and I have necessary in the next line. Now, if implementation details and exposing only D is not running, the next line won't run. That's the essence of being in an interpreted language. Unlike the compiled languages, which are like C++ or C. C++ or C, even though there's an error in the code, it's going to compile the code, but in course of compiling, it's going to tell you where that error was detected so that you can go ahead to fix that error. The difference between C++ and Python is that Python gives you this, both of them are both high-level language. Please don't get me wrong. They're both high-level language. So Python gives you this ability to correct your mistake before you move on to the next step. I'll be showing you something about what the I think the inventor, I'll call it inventor, yeah, of Python wrote. There's a manual by the inventor, and we'll be looking at the different concepts he told us about Python and the benefit of Python itself. Okay, so this abstraction, this involves hiding complex implementation detail and exposing only the necessary part of an application. Now, the benefit of the abstraction, one include reduces complexity, two include improves understandability. The third one is allows focus on essential features without getting bogged down in details. So example, a car steering wheel is an abstraction. Driving does not need to know, like drivers does not need to know the complex machines behind steering. They just need to know how to use the wheel. That is the meaning of abstraction. It's a very, very basic example. A car steering wheel. Those of you who has a car or who drives here, you will know that when driving, you don't have to know the mechanism or the future involved in that steering wheel. Yours is just that, okay, I should ensure that as soon as I'm driving, I should ensure that I know how to turn my steering wheel. I know how to rotate the steering wheel and so on. You're less concerned about which direction is going to. You know, when you turn the steering wheel to the right, it will turn to the right. But, but that mechanism is not meant for you to be understand. You just have to know that I'm driving a vehicle, and when I turn to the right, it turns to the right. When I turn to the left, it turns to the left. That is abstraction for us. Now let's look at the next one. The next one is called encapsulation. Now, all these concepts I'm mentioning are concepts in any object-oriented programming languages. Object-oriented programming languages are programming languages that has what classes. When they have classes, simply means you can assign an object to that class and call that class. I'll show you a basic example of that maybe in the course of the program itself. Now, this principle involves bundling data and the method that operates on that data within a single unit of objects. Don't worry, the definition might be hard to get, but an example will give you a much better view of this definition. Now, the key benefit of encapsulation, information hiding. That is, internal details are hidden from the outside world. That's information hiding. The next one, access to an object data is controlled through methods. I'll show you what I mean by that. The next one, protects the integrity of an object's internal states. Now, this is an example. In object-oriented programming, a class encapsulates its attributes and provide method to interact with them. You might not still get this, please, I know you might not still get this example I gave down here, but in the course of the program, maybe when I'm about to start writing some code or some program, as the case may be, I will show you what this encapsulation simply means. But just note this word, a class encapsulates its attributes and provide method to interact with them. So just note this word. We'll be seeing how this class encapsulates something and so on. Now moving on to the next one. We have separation of concern. These principles suggest dividing a program into distinct sections, each addressing a separate concern. It is very, very important. Now, one of the benefits is improve maintainability when you separate your code into different concerns. Maybe the user authentication should be different from the UI rendering of the application you're trying to build. UI stands for user interface. So that interface might be what the users are saying. The user authentication is the way the user will be authenticated when they fill in their login details in your UI, which is in a browser form or a mobile application. For instance, in a mobile application, when you open up a mobile application, most mobile application will ask you, okay, let's go like this fintech kind of application. When I mean fintech, I'm talking about financial kind of applications. Let's say your banking apps, let's say like OPay, for instance. At the first instance, if you don't have an account, it's going to ask you to log in. That first interface you are seeing is called the UI. Now, the way that information is processed is called the authentication. So separation of concern can be the way you handle the authentication and the way you handle the UI rendering. Now, it makes the system more modular, and we have seen this one, breaking things into simpler parts. Example, in a web application, the business logic, data access, and user interface are distinguished into or defined into different layers. So I just said, and user interface are just said into different layers. It's the ability of you putting different logic, like what I just explained now, the UI itself, which is containing the form and what it is displaying in long run. Okay, so let's look at the next one. Oh, I'm sorry about this. This is a duplicate. The next one is don't repeat yourself. Dry. This principle aims to reduce the repetition of software pattern, replacing them with abstraction or using data normalization. I'll show you the meaning of this abstraction, like what I've said already. Abstraction, like a car driving wheel. The driver doesn't necessarily have to know the essence of the mechanism involves in the steering wheel. You just have to know that when it turns left in the driving wheel, the wheels turns, that's the tires turns left, and when it turns right, the tires turns right, and so on. So the key benefit of this concept, don't repeat yourself concept, is that every piece of knowledge should have a single unambiguous representation in the system. The second one is that it reduces redundancy. Redundancy simply means writing a code over and over again. So one like the logic repeating itself over and over again. So it reduces that redundancy. And the third one is makes the code more maintainable. Yeah, it gives the code a clear structure and it makes it more readable. Example, instead of copying and pasting the same code in multiple places, create function that can be reused. So instead of you copying, maybe you have a code or a business logic or a logic where you wrote how to check for maybe a simple even number checker, something like that. That's a Python, a very, very basic Python script, or maybe any other programming language script to check even numbers. Now, there's a case scenario where you have to be writing your if and else statement over and over again. To avoid that, you can create a function to undo that if and else statements. I'll be showing you what I mean by that function, and how it can save us time and make the code more flexible. Now, the next one is solid principles. In software engineering design or software engineering, as the case may be, or software development, all the same. Now, there are 5 principles of object-oriented programming designs and object-oriented programming, as the case may be. Object-oriented programming is just simply what I explained the first time. Like Python is an object programming language. It makes use of classes. Now, those classes can be called using what? Objects. I will explain that in the course of writing the code so that you can understand the meaning of object programming languages and so on. Now, the first thing we have here is a single responsibility principle, SRP. A class should have only one reason to change. Each class or module should focus on a single task or responsibility. This aspect comes to play with one of the concepts in object-oriented programming called inheritance. So we create a class, we see how another class can inherit this class and override the content of this class, not like overriding the content completely, but adding a new feature to that class instead of you going back to that class to edit the class. So that aspect of things is called single responsibility principle, SRP. Now, we also have open-close principle. Now, software entities should be open for extension, but closed for modification. You should be open to extend a class behavior without modifying it. I'll also explain this concept in the course of writing the code. Now, Liskov substitution principle, LSP. Object of a superclass should be replaceable with an object of its subclasses without affecting the correctness of the program. Okay, this aspect also has to do with one of the concepts of object-oriented programming, which has to do with inheritance. We'll be seeing how object of a superclass can be replaceable with object of its subclass without affecting the overall program itself. So that aspect has to do with classes in the object-oriented programming space. Now the next one is the interface segregation principle, ISP. Many client-specific interface are better than one general purpose interface. No client should be focused to depend on method it does not use. That is the ISP principle. Now, most of these things might be new, please, but I will explain these things in the course of writing the program. Now, dependency invention principle, DIP. This is an high-level module. A high-level module should not depend on low-level module. Both should depend on abstraction. Abstraction should not depend on details. Details should depend on abstraction. All this concept might be something new to most of us here, but most of us who are undergraduates, most of us who are taking courses in computer sciences and engineering would not find this thing difficult, because in the long run, even though you're hearing about them for the first time, in the long run, in the course of a program, you will hear all about this. There are always concepts we use in engineering and also in computer sciences to analyze or break down some terms and concepts. Now, most of these concepts are new, but when I start writing the code, I will explain most of these concepts in there to you. Okay, now thank you for the stage. So far so good. Please, if you have been following along, please, I need a thumbs up before we start implementing or writing one or two programs. Okay, thank you, Mr. Emmanuel. Mr. Watsubi Abasi, are you lost or we are still in shape? Mr. Chike, are we still in shape or you missed out? Okay, please go ahead, Mr. Chike. You want to say something?
I'm following, though my network has been coming off and going off, off and
Oh,
on.
apologies for
But
that, sir.
I'm following. I'm following.
Mr. All right, all right. Thank you for that, sir. Mr. Otube, are you still with us or you have left us?
I'm following.
All right. Now let's jump to the course of writing the program. It is very, very essential we use the Python program itself. So I don't think today I will continue with my the web aspect of what I was building in the last class, which was on Monday, since most of us um don't have idea on the programming language we'll be using. So the first thing I would do is coming down to my browser interface or there's a code editor I'm using called Visual Studio Code. But for most of you that don't have this, I would like you to follow along. So I'll be using my IDLE. IDLE stands for Integrated Development Learning Environment, IDLE. So I'll search for that. If you have Python installed on your PC, you can just search instead of me using my VS Code so that I don't get people confused. The newbies in the house should not get confused. So what I'll do is that I'll search for IDLE. Okay. This is kind of running slow. I'm sorry. Let me close some applications in here. Let me close this application. Okay, my PC is kind of misbehaving. I think there's an update running at the background. Okay, and my battery is almost running low also. But save ourselves time and all right, so we have the application open up. Now this is an IDLE. An IDLE is the Python interpreter which can be gotten from, for those of you who have not downloaded the Python interpreter, you can simply go online, open a new browser and search for Python Now in the course of searching for Python, the first result will be the results you have to use. So you will click on this welcome to python.org, which will take you to the Python website itself, python.org. And in here, you will go down to download and come down to the operating system you're using, Windows or Mac. And for other platforms, we have them here. So for Windows, once you come down over there, it's going to bring out a pop-up by the left-hand side or by the right-hand side. So you can see download for Windows. You can click on download and start downloading this. Good. Okay, then back here in the IDLE. So once you download and install it, this is what you'll be having. You'll be having this interface, IDLE. Now, this is an interpreter itself. The first command we'll be typing here is the import this. We want to see what the developer said about Python. Now, when you type import this, you're going to be having the Zen of Python by Tim Peters, which I feel is the developer of Python. Here are some instructions or some basic description he gave about Python. He said, beautiful is better than ugly. So Python codes are structured in such a way that they are readable and they are more straightforward compared to other programming language. Now, explicit is better than implicit. So all this description by the founder of Python, which is the Zen of Python, are very, very essential. And these things are the key concepts we'll be using when writing our program, for instance. Now, this interpreter is going to limit us to in writing our program. So we have to go down to File, to the top menu here. This top menu, we have a file. We click on New File, which is going to bring up a new blank screen on top of the screen. So this is a new blank window in here for us to type our code. So in here, what we would like to do first of all is talk about functions. Remember, I was talking about a simple even number checker. Now in Python, there are various kind of things you have to learn. So for those of you who don't have an idea of this, I would advise you take the data science, data analytics class, by the way, so that you can be introduced to this. Saying the introductory class offline offer features based on Python and everything you have to know about Python. So in here, we have something called comments in Python. The comments can be an hash or a triple quote, which is called a multi-line comment. Now, this is the difference. This single line comment is used to pass a single set of instruction to the user, just like a description of what your program is talking about. So I'll say even number checker, for instance. Now, if I need a multi-line comment, I'll use this triple quotes and use this triple quotes. Now, there's also another one. The multi-line comments can be triple quotes, 3 triple quotes, and closing 3 triple quotes. It can also be 3 single quotes and closing 3 single quotes. So these two are considered the multi-line comments. So I'll call this guy single line comments. I'll call this guy the multi-line comments. Now, the essence of these comments, like I said, is used to make your code readable by a user who is trying to utilize your code in the long run, or your program. So I will not call it code, but program, the program you're trying to run. So this is a multi-line comment. Now, the difference between the single line comment and the multi-line comment is that in a single line comment, you can split the word even, number, and checker. So that's the difference between the single line and the multi-line. The single line is used to pass a brief description of what the project you're trying to build or the program you're trying to build is talking about. That's the what multi-line comments. And the single line comment is just a single entity, or maybe this program is for this program is for this. Why the multi-line, the description of it. So I'll not be going down to this. Now, the first thing I'd like to do is to create what we all know, data types in Python. So there are different kind of data types in Python. For those taking the Python classes, we have the string data type. So I'll use a single line comment to hold this. Number 1, the string data type. We also have the integer, the int data type. Is the int. We also have the what do you call this? The boolean, the bool data type. In Python, we call it bool. We also have the float data type, which is called the float. Float are actually decimal, floating point number, decimal numbers. Okay, so these 4 data types are the very, very important data types in Python. Optional data types include the binary, which are of different types, and the binary and the hexadecimals. So in the course of this program, we'll not be looking at this, the binary and the hex. We're looking at the 4 basic important data types in Python. Now, the string data type are in quotes in a what? In a string, in a quotes. Why okay, I'll just give an example here. E.g., for something to be in a string, it has to be in a what? In a quotes. So here I have a name. Why the number, the int must be a number, example 8. The next one, the bool is either a true or false statement. So true and false. And the next one is the floats, which is actually a decimal number. So that is a float. Then for the binary and the hexa, we're not considering that. Now let me explain those concepts of the solid principles using object-oriented programming. Now, since Python is an object-oriented programming, is an object-oriented program, by the way, it makes use of classes. Now, let's say class A. This is a class. I've created a class, and in this class, I don't have any attribute passed. So I'll use a pass statement. The pass statement is used to tell the interpreter that that class is empty, just pass without displaying any information. Now, for me to be able to access class A, I have to assign class A to an object. Assigning class A to an object, I have to define object underscore A is equal to A, open and close a parameter. The reason why I'm opening and closing a parameter without passing anything inside this parameter, which I will call arguments, is because my class is empty. If my class contain extra information called constructor, then I'm going to pass that here. Now, since I already have class A, I will print out the objects so that I can see that object underscore A. Now, the reason why I had to jump the rest of the stages down to classes is because I would like you guys to attend the data science class or data analytics class. One of those two classes, I think they have started the introduction to Python, or that's what they're basically doing. So when you attend those classes, we can then flow together. But for now, going back to teach you introduction to Python isn't part of the software engineering class or the session, as the case may be. So printing class A, print A is going to return. For us to run this program, first of all, we have to save this program. So I'll come down to File, look for Save, Control S. It's going to ask me to select a space where I want to save this. I'll click on Desktop. Notes, come down to Desktop, because Desktop is where we'll be saving most of our projects. So I'll click on Desktop and come down to the software engineering. Let's see if it's here. Okay, come down here to software engineer, software, and call our program classes, object oriented, OOP. Good. Now you can see that I'm printing out an object. Now the next thing after saving my file is to run that object. So run module is going to be displayed here. Now you can see that my class, which was empty, was printed out with an address that was used to store that file in my local machine. But we don't want this because this thing doesn't carry any information we need. But as a software engineer, we have to be exposed that this information passed here is the address of that file we save in our desktop in our interpreter. But we don't want this. What we want is that we want an information passed to that class so that the class can be displayed for us to be viewed. So we'll come back here, and in our class, we'll create something called a class constructor or a class attribute. Let's start with the class attributes. A class attribute is simply defining something inside the class. Like, let's say, sit is equals to true. Now, if you come down here, we can use that object to target the class attributes. What's the class attributes there? The class attribute is what? Sit is equals to true. So we're expected to return a true statement right here. Now let's run this program and see. We're having a true statement return. The reason why we're able to do this is because the class now has an information in it. And that information is sit is equals to what? True. So after assigning an object to that class, the object now has what? It now has a way of accessing the class. So since I've assigned object underscore A is equals to class A, the next thing I'll do is to use the object to target the class attributes in that class. Now this is for attributes. Now let's look about what about a class constructor. A class constructor is used to define information that we need to pass in the class. For example, we use the def keyword for those who have done introduction to Python, and we use the self. The self will target the object we want to pass to the what? To the class. Let's say name, and let's say course. So these two things. Now we will use the what? The self, which is what we want to pass to the what? To the class. Self.name to be equals to the name. So we are assigning a name we'll pick, which will pass to the objects to the class. It might be a bit confusing for those who doesn't have idea about Python. But me going back to the introduction might be something time wasting. So I feel that you should also try as much as possible, please, to take the introductory to Python class so that you can have idea or be exposed about these things. So try the next one. Self.course is equals to course. Now this is a constructor. You can see that this constructor has a name and course, but those name and course has not been defined. For we to be able to access this constructor is that we have to pass a name to these objects. So where we have A now, A can simply accept what? Arguments. Which argument is it accepting? Name and course. The self is used to assign the name and the course. Note, this self can be any name. But just note that the first attributes here, as the first arguments here, will be used to call the rest of the arguments in your constructor. The reason for that is that the self is used to reference what we have inside the constructor. So I have two important things in my constructor, name and self and course. So the self will be used to access this name and course. If I use a different name here like S will be used to access name and will be used to access course. So when I come down here now, I'll specify the name as Sam, for instance, and the course is software engineering in a string. Now this is a what I have to define here is a what is a kind of data type, and that data type is what we have seen, a string data type, because it is only the one encoded or wrapped across with a string, which is a quote, as the case may be. Now after doing this, so I'm good with this, I'm done. I can't display this information. I don't want to access seats. I want to access what the constructor holds. For me to be able to access what the constructor holds, I will have to create a function. Now that aspect is what we call encapsulation. Like if you see what we have done here, the first case, this code sit is equals to true has been encapsulated inside the what class. Sit equals to true can only be accessed by accessing the what the class. That is the meaning of encapsulation. It has been encapsulated inside the what inside the class. It has been placed inside the class. If you try accessing sit outside the class, it will no more be an instance of that class, because what it is not stored inside the class. The other one, called the def init self name and course, is also encapsulated inside the class. So if I try accessing it outside the class here, I'll be having an error. Okay, let me say print. I'll be having a name error because this guy doesn't exist. Okay, moving from there, I can access it. So I'll comment this. Let me take it down so that you can understand. Now I'm bringing it down in here. I'll create an object, call it object underscore A. I won't call the class. Look at what I want to do. I won't call the class. I want to call that sit. So I'll say sit. I'll say object.sit. Let me print this out and let's see the error we'll be having. The reason why we'll be having an error is because sit was inside the class, has been encapsulated inside the class, and I'm calling object.sit. Object wasn't defined in the first place, and sit also wasn't defined. Sit was only defined inside the class, not outside the class. So me calling object on the .sit, we throw an error. Now let's run this program. Save first and run the program. Yes, we save the program and run. And here we have an error. Object underscore A is not defined. The reason why that object underscore A is not defined is because the objects underscore A has not been assigned to the class. So you can't call something that has not been assigned to the class out or target it or target an item on an attribute of the class to that variable. So this object underscore A is called a variable, and it can be called alone on its own because it has to have access to this class. If it doesn't have access to this class, it can be called in that class. Now, for us to avoid this, what we can do to get sits is by creating a new object underscore A. We assign it first of all to the class A. After assigning to the class, it doesn't still understand what A means. A is a class which has to be wrapped with what? A bracket. Now, so A has been assigned, that class A has been assigned to an object. It simply means now that the object can be used to access anything in the class. The object attributes, the class attributes here, and also the class constructor. That is what it means. So let's access the class constructor. Print, and the class constructor will not return anything because that variable has no print statement inside of it. Let's print this dot init. Right? This is what we have, right? And let's run this program and let's see what the outcome will be. Yes, we like to save that. Now we have another error. Init missing two required arguments, name and this. Okay, so let's pass this argument. It requires the name, which will be in a string, Sam. The course, which will be data science. And so on. Now, we have access to the what? Initially, notes, initially we assign an object underscore A to what? To the class. So since we have assigned an object to the class, it simply means we can use this object now to access any item in that class. So object dot this will give us the attributes of that class. Now we're having missing to require arguments, self and this. That's because the init argument itself needs a way to read the information, but we haven't passed that information in that class. So we'll throw this away. We access the class, just like what we did here. But before we proceed, we'll create another function that will display the information the user is passing to that class, or what we are passing to that class. We'll call this outputs, def outputs. And this output we accept self, which is the objects. And we'll then display return. This is another method in Python used to what? Return and print are two different things. The print is used to display the item or the program or the code to the terminal. So anytime I use print, it displays it here in this interpreter. The return stores that information and returns that information over and over again. But it doesn't display it out to the terminal. For we to see it in the interpreter, which is the terminal here, we have to use the print statements. So return self. Now, since I'm creating another function, this other function I'm creating, we have access to the constructor. And remember, self was used to access the what? Name, and also used to access the course. So I can say return self.name. Then we concat it by using a plus, since both of them will be a string. If it's a string and an integer, it's going to flag us an error. But if it's a string and a string, it's going to what? Concate. So we'll do self.name plus self.course. Now, after we are done accessing A and passing those attributes, I can come down here and print objects underscore A dot output. So while you're running this program, object underscore A dot outputs is going to display out the outputs. Okay, I think I facing a little bit of issue here. Let me comment out this guy. Let me save my program. Then, sorry, let me see. Okay, yeah, a little issue there. It's just saying, yeah. So I have what? Sam software engineer. So the outputs here display the information I passed in the class, Sam and software engineering. Okay, I know this guy might be a little bit confusing, but I'm just trying to explain the concept of encapsulation. So the concept of encapsulation, from what you can see here, is that anything defined in a class can only be called when the class has been called. If the class hasn't been called, you can't call those attributes or those constructors in that class. It won't allow you access that class. Now, for the constructors are used to define usable terms, like what we want our program to have. For instance, I want my program to have a name and a course. So when I come down here, I'll specify the name and the course. For me to see what the constructor is giving out, I have to specify a function called output. I know the word function might be a new word also. So let me give you an instance of this function. Let's say we want to create a simple evil number checker. Now, before we can do this, we have to accept, we have to write an algorithm. I think we have looked at the algorithm in the last class. So the first one is what starts the program. That's the first stage in the algorithm. It starts the program. The second stage is what gets the inputs for the program. And this thing it will fail. The reason why it will fail is because we need a multi-line comment to comment that code out. So let me just bring it up a little so that everybody can see that. After we get the inputs, the third one is check if the inputs is even or odd. For those of you that attended the last class, I told you the meaning of algorithm. An algorithm is a step-by-step procedure or process in what's in achieving or in achieving a program or running a program. Yeah. So after we get the input from the program, we check if that input is even or odd. If the input is even or odd, we return. Yeah, we said return the results. Return the results. Then after that, we end our program. Now, this is one of the concepts we use in software engineering, an algorithm. We have written what our program will follow, the steps our program will follow. So let's start to implement this. The next thing we have to do, though, is to draw a flow chart using some boxes. So there's going to be like a visual to show that, okay, this is how the program will follow. I'll not be doing that flow chart here. And that flow chart will be an assignment you can try out in the course of this program. Okay, now let's start with this program. The first thing is start the program, right? So we say even number checker. So I'll just copy this. Even number checker. The next thing is I'll accept input from the user. I'll say value. That's what I'm getting from the user is equals to int. I want the user to what? Input a number. It must be a number. That's why I'm using the int. And I use an input statement. Now I'll show you the reason why I'm using an int. The int is actually used to convert the input itself, accepts anything as a string. Even though you pass 7, you pass 7.5, you pass true, you pass false, it's going to accept it as a what? As a string and return true for us. So to avoid that, we'll be using the int. Now, this int also has a limitation. It simply means it will accept only integers, which are what? Positive numbers. It won't accept a float. It won't accept a boolean, which is a true or false, and it won't accept a string. So it's going to be throwing us an error. For we to tackle that error, we're using something called the try and except block. That's something we call error handling in Python. Every programming language has a way of handling errors. So I will explain that. I will try that out here. So we have enter a number. Yeah, we enter a number. Then now we check using the conditional rendering or the branching rendering. Say if value is divisible by 2 and the remainder is 0, that number is what? We say print. I'm going to print the value. I'll use the f string pass a curly brace. In Python, we do use this curly brace to store values that are undefined by us, but are defined to but are what's defined by the user. So that value is the value we'll be getting from the user. It's not a fixed value. We don't know what the user might pass. Anything the user might pass, it will get that value and store it in that string and display it out. So value is what's even. So we close this. Then we use the else statement. Else print. We use this also and get the value in that curly brace. We say value is odd. Good. Now, if it is true, if the number is divisible by 2 and the remainder is 0, it simply means an even number. The program is going to end. So it's going to return the results. It's going to return the results and then end the program. So it has followed our algorithm. We started the program. We want to get the input from the program, which is what we're doing here. Value is equals to int input this. Now we check if value input is odd or even. If it is what? Even, return the results and what? End the program. A simple algorithm. Now let's run our program. We save this. We come down here, and here we are having a prompt showing what? Enter a number. There's a prompt down here, by the way, that's showing enter a number. So we go down there and you click. We left click on the item there, so the cursor will blink on that particular prompt. Now type 7. We all know that 7 is an odd number because it is not divisible by 2. Or it's divisible by 2, but the remainder is not 1. Sorry. It is divisible by 2, but the remainder is not 1. So it's going to return what? 7 is odd number. So when I run this, it's saying 7 is what? Odd, and my program has run. Now running the same program again, I'll bring back the previous script. I'll try again, but this time around, I'll be using an even number. Come down here and click on it and specify 6. And we're having what? 6 is even. So with this simple set of program, we can see that we have written an algorithm for this program and also what? Implemented the program based on the algorithm. Implemented the program based on the algorithm. Now let's come back and implement one more thing. Run this program again. Running this program again, and let's specify 6. That's in words, X, SIX. And let's see the error we'll be having. We'll be having what? A value error. It's trying to tell us that what's invalid literate for int with base 10, 6. It's trying to tell us that 6 is a string. And we have told our program to only accept numbers. To avoid this error, to avoid this issue, we have to specify using a try and except block. And this is what I mean. It's just a 2-line of code. I'll come down here and use the try method. Try. I will indent my code because Python is an indented language also. Indent my code. I'll copy everything and press tab key on my keyboard. Then here I will use the except. Except I'll call this value error. There are different kind of errors. The value error is usually used for numbers. So I will say print. What would I say? I will say invalid number passed. So this is what we do use, especially those who will be focused on the web development aspects. Now, when you're trying to write a logic for your login authentication, you actually have to use an if and else statement here to check if the user is authenticated or if the user is admin. Redirect this user to the admin page, else redirect this user to the home page. So the if, that's the conditional rendering, are mostly used in fact in everyday life case, as the case may be. Now let's run this program. We'll save this first of all, Control S. Okay, it's asking for space. Error on line 28. Let's run this again. Just trying to indent my code. Okay, and now let's run this program. Save the program. Oh, no space left on device. Sorry, my device is actually filled up. All right, I think I will call this a day here because my device is actually filled up. I can't run my program anymore. I have to shut down some of the programs I'm running, especially this web browser. Okay, so an assignment before we move on. Okay, an assignment has been placed on the what? Google Drive. Sorry, the Google Classroom platform. So please try to go through the assignments. Before we call this a day, okay, I think we'll call it a day from here. We'll call it a day from here, but before then, please, let's is there any question or is there any further suggestion based on the class? Any question, suggestion?
Thank you for the class, and what I want to say is, yeah, those ones that are yet to be introduced to Python, you can go for data science class. That will also give them a heads up. Then I also suggest that our videos be sent on the platform so that we can go through the videos and prepare for the next lesson. The last video has not been sent up till now. It has not been sent. So whoever that said he sent it, it has not been sent anywhere. So please, so that those of us that are still grappling with few things, by the time we go through the video over and over, programming is not something you just learn, instantly. It's something you learn by practice. So by the time we go over the videos again, certain things will sit, you know. Thank you very much. You are really doing well. I appreciate.
Yeah, thank you, Mr. Emmanuel. I think I will speak with yeah, with my colleagues concerning the video because I think he said he has sent the video though to the group. Oh, I don't know why we are still getting complaints concerning the videos, but I will try as much as possible to talk with him today and so that we can see on how we can access the video and send the video possibly out today. So is there any other suggestion or any other question?
Yes, sir. Thank you very much for the class. So I was interrupted by network today. Emmanuel have said this a part of what I really wanted to say. So what I want to add to when you started when you opened that page, that was when I went off. It took me some minutes to get back in the network. So what I'm saying on my own, in summary, if I don't know if there is a sort of way all those things we are doing, all those commands, if it can be sent as a note, just like our data science teacher used to help us to do after the class, we send it as a note. So if people cannot see the video immediately, we can be looking at that at least to rehearse and do what we are supposed to do in the assignment. Please. Thank you, sir.
All right, thank you, Mr. Chike. Thank you for that. I'll find a way as much as possible to send that before. I think it's a command line command you're asking for. So I'll find a way to prepare a note to that and send it across.
All right. Thank you, sir.
Yeah. Please, is there another question based on? I know the assignment is a bit tough, but please you can you can check the Google Classroom group and yeah, there's an assignment there which is actually strictly for those who who partake in the Monday class. Those are the ones that were able to answer those questions in the assignments itself. So I would just like everybody as much as possible to try the few ones you can answer. And those ones you can answer, we'll try as much as possible to look at them on Friday. I think Friday is the deadline for submission of the assignments. So okay. So is there any other question apart from that? Apart from what Mr. Emmanuel has contributed and Mr. Chike has contributed? Any other person? I felt I make some people lost in the course of the program itself. Like most of the things I was saying were like new to most of the newbies who were joining the class and expecting me to start afresh with Python itself. That's not my aspect, and that is not what I'll be doing in the course of this program. I will strictly be focusing on the software engineering aspects, that's web development aspect, which is one of the specialization in software engineering. So for those who are having or who are newbies to the Python environment or the Python space itself, please, I would advise you take that data analysis course to learn more, please. Okay, I think it's a data science course. So the data science course, please, is very, very essential. You take that course and we will all be appreciating um, the effort I've been putting so far in what I've been doing, and we will all learn one or two things new. So please, if there's any other question, you can go ahead, drop your question, or if there's none, we can call it a day.
Please, you can still guide us on how, maybe on the WhatsApp, on how we can submit the assignments, because you said we should do it with Google Docs. I did mine, and submission using my phone, because I think submitting with system is quite easy, because Google Docs is synchronized with the Google Suite. But when you are using a phone, you have to Google Drive, Google Docs, they are separate applications. So more like when you get to that Google Classroom, then you enter into the Google Docs through the Google Classroom, then you do it. The only option that will be provided for you is to share. You need to share with a group member or something, or attach a name. I don't know whether there is any other way we can also share after doing the
Well,
classroom,
we will
the
check
assignment.
that out and possibly drop updates concerning that. I feel
All
there's a
right. Thank
way,
you.
apart from sharing, there should also be another way to upload the
All right.
assignment. Yeah. So we'll
Thank you.
get back to you on that. Okay, so I feel there's no other questions as comments or any other thing. So all right, so thank you for today's session, and I hope we all learned one or two things today. Okay, so have a lovely day ahead.
Excuse me,
Thank you.
sir. Excuse me,
Okay,
sir.
yeah, go ahead, please.
And just want to ask, if they've uploaded video and there's something you can't understand, is there any way we can contact you, like privately, directly?
You can drop me a message on the group chat. I will definitely respond
Okay,
based
sir.
on anything you
Thanks,
don't
sir.
understand or based on what the video or based on the aspect the video wasn't clear on.
Okay, sir. Thanks, sir.
Yeah, you're welcome. All right, thank you and have a lovely day ahead.